you've had a chance to work on these problems for a little bit, and I think it would be productive for me to solve a few of them, and let's see if you were successful, right? Now, this, one added, I don't know what you want to say, the silver lining here, something you might be interested in, is that every last one of these I have pulled from your homework. So we are currently solving your homework. All right? These problems are homework problems. Like, I just cut and paste them to here. So if you can figure out which one's which, you already know the answers once we're done with them, right? So here we go. So now exercise 1 is kind of an outlier, isn't it? So they give us minus 3x plus y equals to 4, 4x plus y equals to 4. They give us y equals to 1/2 x and y equals to minus 1/4 x plus 3/2. And they give us y equals y plus 2x equals to 3, and y plus 2x equals to minus 4. All right. And we're supposed to classify the equations below as dependent or independent. And well, wouldn't it figure? I'm actually not sure what the answer to this is, because I'm not sure if your textbook has decided to say that case. To me, I could see that it depends on what they have given as the definition for dependent or independent in the textbook, right? What I'm saying is that there's a version of this test question which is better in my book. And so, if you don't mind, to make this question unambiguous in my book, I'm going to change the question a little bit. So I'm just going to make these all 0. All right, now I can answer the question without any qualms. Are these equations dependent or independent? So 2 equations are dependent if they're the same equation, just rewritten. If it's the same. Yeah, C is like obviously dependent. Now, so I'm not sure. It may be that the book has defined it, like maybe that the answer to that question in your homework is also dependent, because it's saying that even if they have different like y-intercepts, they're still dependent. Like, I'm not sure. That would be a reasonable use of the word dependent there, but I don't know without opening up the ebook and looking at it. I don't want to do that right now. How about this? Independent, right? And these ones, if you look at it, we've got the same coefficient for y, so we can reasonably compare them, you know? Right, so exactly. So these are independent as well. And so essentially, for independent, I can't spell there, independent. If we look at 2 equations and 2 unknowns, they're going to be dependent if they have the same slope, and they're going to be independent if the lines have different slope. I suspect that's the definition given in the book. So the larger point here is if the equations are independent, there's one solution. But if the equations are dependent, there's either no solution or infinitely many solutions, assuming that.
Would that be on the next test?
That'd be like a test 2 thing, yeah. I will circle back to this issue when I've had a chance to investigate the book more, okay? Right, and you notice that the graph, like the graph's given, right? This one is what, like, they're skew. This one, the graph, the lines are skew. And this one, there's no solutions, right? Because they're, well, so the one I drew, when I put the numbers back, it's what I've pictured, right? So
I guess it doesn't matter what the, like how you say like the negative 3x plus y equals 4, so we don't have to like worry about the equal 4 part, like we just
right,
worry about the actual equation.
yeah,
Okay.
that is the case. Yeah, I think I see again. I'm not. This is what I'm not 100% on. The question is whether, when the lines are parallel but don't intersect, if that's still considered dependent.
Okay.
I can see why a person would call that dependent. I'm just not sure if they've actually lumped that into the dependent definition or not. So I could also see an argument for saying that the only case it's dependent is when it's the same equation. You know. So anyway, let's move on. Exercise 2. Okay, so we shouldn't have any ambiguity for the rest of today. That should be it. Question 2, and this one's a little bit easier actually, is -1, 9, a solution for a minus b equals to -10 and a plus b equal to 8. So like an answer of yes or no on this question, I'm going to give like half credit for, because we have to show our work. Okay. So we have a equals to -1, right? And b equals to 9. We're assuming that this is a comma b. Actually, that's ambiguous for my question. But assuming that this is an ordered pair a comma b, a equals -1, b equals 9. And then so we've got -1 minus 9 equals to -10. Check. Right? And -1 plus 9 equals to 8. So yes, therefore, the ordered pair -1, 9 is solution. Yay. All right. So I hope you guys got that one. Sounds like some of you did. Great. Yes, yes was a guess. Half credit. Let's see here. Is 3 minus 2 a solution to a minus b equal to 5, 2a plus b. Oh, I can't write. 2a equal to b plus 4, rather. So what do you guys think? Yes? Oh, yes. Yes and no, then what's the answer? So we got 3 minus a minus 2 equals to 5, so yes. But then what do you say? So 2 times 3 is 6, and that's not equal to minus 2 plus 4. Right, so in other words, thus 2a is not equal to b plus 4. It's not a solution. So I'm giving it a name. This star is a system of equations, right? It's not enough to solve one of them. We have to solve both of them. So that's the thing. So no, not a solution. So we got that. Now problem 4 is our first real problem. All right. So we're supposed to solve this system of equations, and it suggests the substitution method. Now, like on the test, I'm not going to say solve by substitution or solve by elimination. I'm just going to say solve. I'm going to leave it up to you, which is both good and bad, because that means that if you choose poorly, you can make the problem harder than it needs to be. Right? 87. Yowzers. Okay. We're supposed to solve this by the substitution method. So the substitution method says, so you're like plug y equals to 5 minus 4x into that. That gives us 5x minus 3. Remember, parentheses are so important. When you have a multiplication, like, take the time to write the parentheses. 5, don't try to do it in your head, because if you do, you'll forget to distribute or something. Then we distribute. Yeah. I need you to grow your hair back. It is distracting. It is distracting the others. It is distracting the other students. It is distracting the other students. I'm going to have to give you. It's her burping. Five x. You say minus 15? I heard a plus 12x. I'll allow it. 87.
Wait, don't you guys distribute the other part in the middle, like 5x?
Oh, that 5x is there. Oh, you're saying next step.
Yeah, that's what I was saying.
Yeah, next step, we got what? 12 plus 5 is what? 17x. And we can move that 15 to the other side, right?
No, but just add in the step, so we know you did it, because you be skipping steps.
I'd be skipping steps. What do you want? What do you want from me? You say don't skip the steps. Then you say skip the steps.
You do your adding sideways, I do it
I do it
under.
Oh, but I only got this much board space. Okay. All right. You want me to add vertically?
We figured it out.
We good like this now.
All right.
To get the X,
It'll be 6.
and that should be
6.06.
Well,
you got a calculator here, don't you? I thought it was just 6. It's 6. I put it in wrong.
Yes, 102 is 6 times 17. Because 6 times 17, like the way to think about 17 and times this, you think about that as 6 times 10 plus 7. So it's 60 plus 42. That's why it's 102.
That's actually pretty smart. I like that, actually.
Yeah.
I might try that out.
There you go. You can tell your nephews. You got nephews? No. Anyway, x equals to 6. Of course, you guys do have calculators, so like this fancy schmancy in your head arithmetic isn't really relevant.
I should get an air high five, because I did everything correct. Yeah, it's the next step I do.
I'm very bad at high fives, even air high fives.
So now we plug in 6 to the other part, right?
What's that? Yeah. Okay. Yep. Right. So that's half of it. Now we got to go back and use y equals to 5. Yeah. Use the first equation. Don't make life difficult. 4 times 6. So we get 5 minus 24, which is minus 19. So if I had another board over there, which would be wonderful.
Space at the top.
I know, but that bothered. Fine. All right. Solution is 6. Yeah, minus 19.
Now since you do that, it looks a whole lot more simpler now.
Because you already tried it.
I ain't tried it.
Ah.
I told you I didn't try Excel before.
All right, you guys, I'm going to give you 2 minutes. Try exercise 5. The next one. Try do number 5 for 2 minutes, then I'll start writing it, okay?
Can you keep the second part that y'all did? Just
I'm leaving this. I'm not.
let's say leave that one.
I'm going to erase this, though.
Okay, that's good. That's good. Okay, so man, you talk about me being in class now. You got a Latin problem. That's when you gonna watch it.
I didn't say you were the class clown. I just said that your hair was, lack of hair was distracting to the other students. It's distracting. It's distracting to the other students. It's too hot for hair.
I got it out there for 3 minutes and my whole head was quick. So I knew my head was quick. It is a unique problem. I would draw a ball like a year. Something that I can pull off the ball here. You didn't know, Mr. Cook, I'm really Kobe Bryant's twin. I just gotta grow some facial hair. Oh, I'm sorry. Sorry, I'm not. I'm just decent. What's up?
Are you still writing this one? Okay.
Wait, okay, so Mr. Cook, okay, so can you show me okay, so can you show me how to start it? Okay, so I'm looking at how you do this problem. So I'm believing it'll be 5x, then
Were you talking about number 4 or number 5?
number exercise 5, like plugging it in. So what I put like no, I'm just over here. I'm gonna show you. No, I'm gonna show you if I'm doing the right thing. So what I do 5x minus 3, and then plug in 2x, and wait.
Well, first things first, solve that first equation for y.
Oh. No. On number 5. So I get 3 and 4.
Like number 5, the way I would start number 5 is to solve the first equation for y. Because that's easiest. So guys, like general piece of advice, if you're going to use substitution, you want to look for a sort of just a plain variable with either plus or minus 1 on it. And so like I look at this, I go 2, 5, 3, no thank you. Y, I like that. So solve for y. That would be my starting point. Y equals to 10 minus 2x.
Oh.
In fact, here's another bit of advice. If none of the variables have coefficients of 1 or minus 1, probably you should be trying the other method on that one.
Okay, so did I kind of start it off right? Here, I'm gonna show you. I want you to tell me if I'm doing this. Okay, so the way you just did that, so I'm gonna put 5x minus 3, and put that into parentheses, and then put 10 minus 2x, and then put equal 3.
Yep.
Oh, thank you, Mrs. Oh, I might pass my test.
Is it correct?
I don't know yet.
What do you mean you don't know yet?
I'm just working. I just wrote the problem down. I haven't worked it. I'm not magic.
So then,
I have to do the steps. So let's go through the rest of the steps. So we got 5x minus 3 times 10 minus 2x equals to what? 3. Now we distribute. We got 5x minus 30 plus 6x equals to 3. That's 11x minus 30 equals to 3. Now, if I was to write, Kennedy, if I was to write this, then you'd be happy.
You've been confusing me since day one. Then x equals 3.
I, all right, x equals to 3, and then what's y equal to? 4, because 10 minus 2 times 3 is 4, right? So we get the solution 3, 4.
that seems a whole lot easier.
I can do this the rest of the class. Like, that's not a big deal. I just didn't know, like, that's the issue.
That's how I've always done.
Okay, so can you give us 5 minutes for exercise 6 this time?
I can give you 2 minutes. And let's not do exercise 6. Let's do exercise 10, number 10. Number 9? Sure, exercise number 9.
Who's at number 9?
Number 9. Number 9, let's try number 9. So guys, here's the situation. I got to sell my house. So because I'm selling my house in Virginia, I need to be in Virginia. I mean, I could do it remotely, but the thing is, I left the table saw at my house. I kind of need to go pick it up, stuff like that. So that's going to happen like next Friday, but I have to travel up Thursday, which means. So that means I will have someone proctor the test on Thursday. So I just if I move the test from Tuesday to Thursday, then somebody watch you take the test other than me. So.
That's fine, I'm still confident.
Yeah.
I got confidence now after that.
Mm-hmm. Of course, remember, the test is not on what we're currently doing, except what? Except, like, it kind of is, right? Like, once we get to this kind of equation, that is just solving this, if that was the starting point. I mean, that's a very likely test 1 question, right?
That's easy. We can do that. Yeah.
Well, if you can do that, then you're going to get that problem right on test 1, right?
What else is the test on? Like, what's on the break right?
It's on solving inequalities. It's on all the material up to like chapter 1 stuff.
Also, easier stuff.
Remember the quiz? Yeah, it's on the stuff that was on the quiz. Find the domain of a function, find the range of a function. Is this a function? Vertical line test. Hey, well, I'm teaching. I'm teaching like some kind of like technology for teachers class, like Monday from like 5 to 9:20 next semester. It's once a week, 4-hour class at night. Yeah. Wait, that doesn't sound good? Yeah, I know. Yeah, I'm kind of hoping, I have another one on like Wednesday night. I'm hoping that once I get students in that class, they'll agree to like splitting it 2 hours Wednesday, 2 hours Friday. That'd be better. But then I've been told that students won't do anything Friday night. Is Alabama so exciting on Friday night you can't do any kind of school? Just drive home. Ah, drive home I can respect. All right, so guys, this one, we look at it, 2, 9, 9, 9. So like there's nothing, I mean, this one I think we're not going to want to use substitution. We're going to want to use elimination. And by that I mean we're going to add or subtract equations on this one. It's going to be easier. And what do you think? What should we do?
So do I, okay. I was gonna ask me about,
Well, don't you have to, don't you, well, I would usually try to make one of the nines negative so they can cancel, so then I could solve that.
That's good. Right idea, but we can do that by just subtracting, right? So like just take these equations and subtract the bottom one from the top one.
that's the only way I learn how to do stuff.
Well, I don't disagree with her. This is a notation for doing that. I mean, we're doing the same thing to both equations. I'm subtracting 9x. I mean, I can write it out. So we've got 2x plus 9y minus 9x plus 9y equals to 3 minus 1. The thing that makes this legitimate, right, is that we're subtracting the same thing from both sides, right? I mean, it's not the same thing technically. Is this the same thing as that? No, it's not, but that's what we're assuming is true, right? We're assuming that 9x plus 9y is equal to 1. So that is a logical assumption for us, so we can subtract this from the left-hand side, we can subtract that from the right-hand side, and it's all good. And of course, when we do that, the 9y's cancel, right? So we get, what, we get 2x minus 9x, right? Equals to 2, which is minus 7x equals to 2, which gives me, yeah, divide by minus 7, but yeah. So minus 2/7. That's half of it. Well, we still got to figure out why, right? Yeah, that's how students tend to get half credit on these questions. They get to the point of finding the x, they feel this sense of accomplishment, they put a box around it and go, next problem. Done, but you're half done. So guys, which one do you want to use to find y? Okay. So 2 times minus 2/7 plus 9 times y, which we don't know yet, equals to 3. Solve for y. I don't know. I mean, you can get your calculator out. Personally, I'm going to multiply by 7, because if I multiply by 7, I get minus 4 plus 63y equals to 21. All right, step. I know you. I know you're minus 2/7. I'm writing it up here. So the 7/7 cancels, right? And then we have 2 times minus 2. Yeah, multiply by the denominator of the fraction, exactly. So that's why I got 2 times minus 2 is minus 4. The 7's cancel. So we get 63y. Oh, wait a minute. I feel like we had a breakthrough today. The vertical notation breakthrough. It's a game changer.
Can you write that top part like a can you write the top part like
So what I was doing was I was taking this and just multiplying by 7. So when that's I have to multiply. It has to multiply all the way through. Yeah. So when you multiply the equation by 7, it multiplies everything that's added together by 7, which cancels out the 7th. And 7 times 9 is 63, and 7 times 3 is 21. You really do want to get to the point where you can write down what I wrote at the end of the arrow confidently without needing to write that in-between step. Like, eventually you want to get there. But until then, you should write the steps. No, I mean, it is healthy, it is good to be able to go from here to there without writing this in-between step.
He's saying we should. As soon as we see that problem with the circle is, you want us to do like how we did going vertical, like without the extra
Like,
equations.
I could, maybe you need to write the step. I don't know. I mean, but
So could you not distribute that? Like you could have did minus 4, then did 14, but you still get the same answer,
minus 4.
and then just keep the 9y.
Oh, could I solve it like this directly? Yeah, sure. I mean, 9y is equal to 3 plus 4/7, right? Which is 21 plus 4 over 7, which is 25 over 7. So that tells me that y is equal to 25 over 7 times 9, which is otherwise known as 25 over 63. I mean,
That just made so much stuff more simpler for me. Like, I don't know what you did on the top.
it's what I'm doing on the top part is just trying to get away from thinking about fractions. So if I want to get rid of fractions, I just multiply by the denominator in the fraction and it will clear out the fractions.
Oh, no, that seems much easier to me.
Then that's fine. You can do it. Then you should do it this way. If this seems easier to you, you should do it. Do it. Absolutely not. No.
Okay, good. That's all I need to know.
No. Either way, it's fine. What's that? Focus on the top one.
Thank you. I might be able to give substitution and elimination. I just gotta remember which one is which. That's just my own. I gotta remember it.
Well, hey, let's do another one. How about that?
Well, I got told practice makes permanent.
Practice makes permanent. Hey, that's not bad. That's not bad. I like that. So what that means is if you practice the wrong thing, you're stuck, right? So I think the moral of that story is just not to practice because it's dangerous. Sorry, I'll shut up. All right, let's see here. Exercise 13. Oh, no. I mean, it's up to you guys. Do you want me to do another do a word? This is a word problem. We should do a word problem at some point, right? So, here's the statement. And I'm just going to work this with you because I think it's better. We have $6,300. And it's invested, right? Part 1 at, it says 11%. And then part 2 at 6%. Interest, I'm assuming. And it says you earn $533 for a certain year. That was the total yield. And then the question is, how much was invested at each rate? So we need to invent some letters, right, to describe the things we're trying to figure out, right?
Okay, so invested is I.
Invested is I.
The part of it is P.
You want to make this one part 1 P?
Oh, no, invested is gonna be I. We can make that X,
X, all right,
and then we can make part 2 Y.
okay. So you're saying 6,300 is I? Now we got 3 letters. Oh no, we don't cover 3 letters in this course. Oh man, now we're really in trouble. How can we get rid of that I? Poke out the I? Such violence. How is I related to X and Y?
Because it comes to the interest rate, so of course that percentage is the interest rate.
Oh, I was putting I for invested, but now you got I for interest rate. Never mind. Let me ask a more direct question. 6,300, what is X plus Y equal to? Right, because you're investing two pieces, right? Part 1 and part 2, part X and part Y, and the net amount of money you're investing is 6,300, right? How much money does the X investment earn? How do we do that?
Okay, so we got. So you got to find a percentage.
Uh-huh. 11% is what? That's 0.11, right?
So the percentage. So basically, what you're saying, the percentage part, we have to find the actual amount of it, right? 693.
Oh, no. But we don't know what X is yet. All we know is that 0.11 times X, this is the amount of money the X part earns. Plus 0.06 times what? Times Y. So this gives me the part earned by Y.
Equals 6,300.
This is earned from 63. What did you say?
Yeah, I said equals 6,300.
Equals 6,300.
Because you're saying we got to figure out what X and Y is, which is the amount of it, and that's all supposed
Well,
to equal out.
but okay, so like you get $10,000, you invest it in the bank at 6%, right? For a year, you get how much money? How much money do you earn?
Okay, so you got.
No. If you had, let's say $1,000 at 6%, how much would you earn? 60? Yes, yeah, $60, right? Or $100 at 6%, you'd earn $6, right? So, if this is the money earned, right? So what's that equal? What are we told?
533.
Yeah, this should be equal to 533, right? And hey, look, 2 equations, 2 unknowns. That's why we're talking about this. how are we going to, how do you guys think we should solve this system here? Erase it and give it to God.
Okay, so do we have to use the substitution method?
The mathematics of Crefeld dollar. Let's see here. 6,300. Was that minus x? Oh, I'm sorry. I just did what I was asking you. I think we should solve for y, because y is sitting there saying, hey, solve for me. Of course, you could also solve for, you're right, you could also solve for x, actually, so. Right. And so then we've got 0.11x plus 0.06y, which is 6,300 minus x, right, equals 533. Yeah, I'm going to have to get a calculator out here pretty soon. 0.11 x plus 0.06 times 6,300 minus 0.06x equals to 533. And what did you guys say this was? 378. All right, so, and what is 0.11 minus 0.06? 0.05. Time for some vertical subtraction. 3. What's that? 155? Well, I mean, fun fact, 0.05 is 1 over 20. I'm cheating with magic arithmetic. Anyway, you can get a calculator out and do this, yeah?
Could you cross multiply and still give?
I mean, yeah, I mean, of course we could just say x equal to 155 divided by 0.05, and you get your handy dandy calculator. What do you get?
Oh, I divided it wrong. Oh, I got 3,100.
3,100.
Yes, sir.
All right. So then y equals to 3,200.
So that's trying to say that's how much we got to invest in each rate?
Yep.
That's a lot of money. I'm trying to get like that person.
I'd like to find I would like to find investments which are reliably at 11 and 6%. Good luck with that. I mean, it's got to be like a stock or something, right? Like you give that money to the bank, they're going to give you what? 0.25%?
Can we do like a stock
Stupid.
market type of thing? Like, but I mean, it'd be useful though, because it will help us save money too and invest. Stuff we might hit the jackpot.
One more example, and we'll be done for today.
It's like $6 grand.
One more example. Let's look at exercise 11. We've got 2x minus 6y equals to 4. And we've got 2x minus 6y equals to 5. Right, yeah, I mean, elimination's kind of be a bear here. What happened? Oh, I've got 2 exercise 11s. Sorry, the second exercise 11. You know, this is why I can't be a number theorist. I've never been very good at counting. But sorry, joke. That was a joke. It's also true. Actually, the main reason I can't be a number theorist is I've never been terribly interested about primes. Number theorists get really interested in prime factorizations of numbers and stuff like that. And I just can't get. Anyway, so what should we do? Yeah. Okay, and when we do that, what happens?
0, 0.
So it looks like we've got 0 equals to minus 1. No solution. That can happen.
Sweet.
Do y'all know when that little thing is happening for that room?
So here's what's going to happen next class, guys. Next class, at the start of class, I'm going to don't lose this sheet. So next class, start of class, you will work the rest of these. We'll talk about the solution to those. And then the remainder of class Tuesday, I will talk to you about polynomial functions and multiplication of polynomials. All right? That's the plan.
Oh, dang, that's as soon as I get out of bed.
Hey, did any of them have writing class tonight?